Children, let us continue the chapter Gravitation. It is already discussed about the gravitation and gravitational force. Then what is gravitational force? Newton concluded that all the objects in the universe are having gravitational force. Every object in the universe attracts every other objects with a force called gravitational force. And also he gave the law of gravitation, which is termed as universal law of gravitation. Then what is the statement of the universal law of gravitation? The statement of the universal law of gravitation is as follows. Every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the center of two objects. And what is the statement of the universal law of gravitation? Every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of the two objects. Now let us consider the two objects A and B. And you know that A attracts B towards it and B also attracts A towards it. Here this arrow mark indicates that is the force of attraction by the B. That is, B attracts A towards it. And this direction shows that A attracts B towards it. Then the force of attraction is directly proportional to the product of the mass of A and B, and it is inversely proportional to the square of the distance between them. Inversely proportional to the square of the distance between them. And the force is along the line joining the centers of the two objects. Here, according to universal law of gravitation, you can write F is equals to G into M by T square. Here, you consider that object A and object B. The two objects are A and B, and M is the mass of the object A. And small m is the mass of the object B. Then, according to universal law of gravitation, the force of attraction between the two objects is directly proportional to the mass of the object. So, you can write F is proportional to M into M. F is proportional to M into M, where capital M is the mass of the object A and small m is the mass of the object B. So, F is proportional to M into M. M into M, that is F is the force of attraction, that is the gravitational force between the object A and B is directly proportional to the product of their masses M and M, capital letter M and small letter m. Here M is the mass of the object A, this M is the mass of the object B. And also F is inversely proportional to the square of the distance between them. Inversely means we have to take 1 by d square. Here F is inversely proportional to d square, means F is proportional to 1 by d square. Inversely means you have to take that in the denominator. Inversely proportional to the square of the distance between the object. Here the distance between the object is d. Distance between the object A and B is d. So we have to take F is proportional to 1 by d square, that is nothing but F is inversely proportional to d square. F is inversely proportional to d square is same as f is proportional to 1 by d square. Now let us combine these two. Consider this is the first one, this is the second one. Now by combining from first and second, you can write here f is proportional to m into m by d square. F is proportional to m into m by d square. Then you can write here, to make it equalize, you can write it as f equals, to write it equal you must take some proportionality constant. Let us take the proportionality constant is g, so that becomes g into m by d square, or g m into m by d square. Here g is the gravitational constant which acts as a proportionality constant in the universal law of gravitation. Then also you can write f into d square equals g into m into m. F into d square equals g into m into m. So here A and B are the two objects. A is a object of mass m, B is a object of small letter m. Mass here, mass of this B we have taken as small letter m. And the distance between them is d. M and m, they lies between the distance d from each other. Let the force of attraction between the object F we have taken here. According to the universal law of gravitation, the force between the two objects directly proportional to the product of their masses. That is, F is proportional to m into m, and the force between the two objects is inversely proportional to the square of the distance between them. We have taken here. And combining these two, you will get, that is, from first and second, combine these two, you will get f is proportional to m into m by d square. Then that becomes, here we have to take, it is already discussed that to make it equal, we have to take some proportionality constant. Here we have taken g as a proportionality constant. That is, the g is the constant of proportionality, and it is called the universal gravitation constant. It is called the universal gravitation constant. And by multiplying crosswise, we will get f into d square equals g into m into m. Then g becomes equals to, here you write g equals, interchange LHS and RHS, g into m into m equals f into d square. So what you can write here, g equals f into d square by m into m. So the formula to find the gravitational constant is g equals f into d square by m into m. That is a universal constant. Now about the SI unit of the gravitational constant, universal gravitation constant. Then here you know that the unit of force is Newton and the unit of distance is meter, so it becomes nm square, and the unit of mass, that becomes kg into kg. This mass is kg, this mass is also kg, so kg into kg becomes nm square by kg square, nm square by kg square. Then that becomes nm square kg to the power of minus 2. That is the SI unit of the G. SI unit of the universal gravitation constant. Universal gravitation constant unit is nm square into kg to the power of minus 2. How you got it? By using the unit of all this. Unit of SI unit of F is Newton. SI unit of D is m. So it becomes m square. Then SI unit of the masses are kg and kg. So it becomes Newton meter square kg to the power of minus 2. So you take, therefore, how you got the unit here? By taking the unit of each physical quantity in the relation. SI unit of so right, G is what? What is G? G is universal gravitational constant. Universal gravitational constant. Then what is the SI unit of? So you can add only gravitation. Then SI unit of G. G is what you have taken? Newton meter square nm square, and by kg into kg, that is kg to the power of minus 2. Kg to the power of minus 2. nm square kg to the power of minus 2. Then what is the constant here? The accepted value of G is the value of G. We have taken value of G equals 6.673 into 10 to the power of 11 Newton meter square kg to the power of minus 2. Newton meter square kg to the power of minus 2. Now let us write the statement of the Newton's universal law of gravitation. Write the statement here. Every object in the universe attracts every other objects with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Square of the distance between them. The force is along the line joining the centers of the two objects. The force is along the line joining the centers of two objects. Centers of two objects. So what is the statement of Newton's universal law of gravitation? Every object in the universe attracts every other objects with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of two objects. Then according to the universal law of gravitation, you can write that F is equals to G into M by D square. Here capital M and small m are the masses of the two objects and D is the distance between them. The force of attraction between the objects with mass m and m is equals to what? F is equals to G into M by D square, where D is the distance between them. That is according to the Newton's law of gravitation. So you take, let A and P are two objects. M is the mass of A and small m is the mass of B. D is the distance between them. D is the distance between them. Then F equals M, right? G into M by D square, where G is gravitational constant, where G is gravitational constant. Now you write about the universal gravitation constant, that is, its symbol is G. Know that G equals F into D square by M into M, and G is what? G is the gravitation constant. How you got it? You got it from by using the F is equals to G into M by D square. This is the gravitation constant. So you write that in the equation, F is equals to G into M by D square. G is the proportionality constant. And it is called gravitation constant, universal gravitation constant. Universal gravitation constant, universal gravitation constant. And G equals, you can write the formula, F into d square by m into m. And the SI unit, that is Newton meter square per kg square, or Nm square kg to the power of minus 2. And value is 6.673 into 10 to the power of minus 11. So write SI unit of G is Newton meter square per kg square, or Newton meter square kg to the power of minus 2. And accepted value of G is, accepted value of G is 6.673 into 10 to the power of minus 11 Newton meter square kg to the power of minus 2. Newton's gravitational law is said to be universal law. It is termed as universal law of gravitation. Why is it called universal law? It is applicable to all bodies, whether the bodies are big or small. And also it is applicable to all distance, whether they are celestial object or terrestrial object. Take that Newton's gravitational law is said to be universal law because first one, you write, it is applicable to all bodies whether the bodies are big or small. Whether the bodies are big or small. Second one, let us write, it is applicable to all celestial objects and also to all terrestrial object. Newton's gravitational law is applicable to all the celestial objects, means it is applicable to all heavenly objects like stars, galaxies, planets, etc. And it is also applicable to all the objects on the earth. Terrestrial means it is applicable to all the objects on the earth. And it is also applicable to all distances. It is applicable to all distances. The objects which are close together or objects which are far away from each other. So, because of all these reasons, Newton's gravitational law is said to be universal law. Now let us discuss about the characteristics of gravitational force. Then what are the characteristics of gravitational force? Gravitational force is a action at a distance, that it does not need any contact between the two bodies. You know that there is a gravitational force between the moon and the earth. Is there any contact between the moon and earth? No. Even though there is no contact between the moon and the earth, there is a gravitational force between them. So gravitational force is a action at a distance. It is a force without contact, non-contact forces. Already you learnt about the contact force and non-contact forces. This gravitational force is non-contact force. Right, first one, gravitational force is action at a distance. Gravitational force is action at a distance. Action at a distance. It does not need any contact between the two bodies. It does not need any contact between the two bodies. As it does not need any contact between the two bodies, it is a action at a distance. Gravitational force is an inverse square force because it is inversely proportional to the square of the distance between the two bodies. It is inversely proportional to the square of the distance between the two bodies. As the distance between the object increases, the gravitational force decreases. Saying that F is inversely proportional to the square of D means, you take for example, D gets bigger by factor of 5, D gets bigger by factor of 5, then F becomes 1 by 5 square. 1 by 5 square times smaller. That is 1 by 5 square means 25 times smaller. 25 times smaller. That is the F is inversely proportional to the square of D. That is, if D gets bigger by a factor of 5, then the F becomes 1 by 25 times small. So as the distance increases, the gravitational force between the two objects decreases. So you write that gravitational force is an inverse square force. Gravitational force is an inverse square force. An inverse square force. Inverse square force because it is inversely proportional to the inversely proportional to the square of the distance between the two bodies. Square of the distance between the two bodies. Square of the distance between two bodies. And gravitational force between two bodies form action-reaction pair, because you know that if there are two objects A and B, A exert a gravitational force on B, that is nothing but action, then B also exert gravitational force on A, that is the reaction. So you can say that gravitational force between two bodies form action-reaction pair. Then you write gravitational force between two bodies form action reaction pair. Action reaction pair. Force exerted by one object on the other is action, and in reverse the force exerted by the other object on the first one becomes the reaction. Therefore, gravitational force between two bodies form action reaction pair. Then let us take the fourth one. Gravitational force between two small bodies is very small, and the gravitational force between two large bodies is very large. Here, the gravitational force between two tiny particles or two small bodies is very small. That is, gravitational force between atom and atom and molecule. And if you take any two balls, the gravitational force between the two objects or two bodies is very small. But the gravitational force between two large bodies like Sun and the Earth is large, as you know that gravitational force is directly proportional to the mass of the object. Therefore, as the mass increases, the gravitational force also increases. Therefore, you take gravitational force between two small bodies is very small. On the other hand, gravitational force between two large bodies is large. So take, for example, you take gravitational force between you take two atoms is very small. Two balls is also very small. But you take gravitational force between Sun and Earth is large. Similarly, you take Moon and Earth or Earth and Moon. Earth and Moon is also large. So, now let us solve a numerical problem based on the Newton's law of gravitation. What is that question? The mass of the Earth is 6 into 10 to the power of 24 kg and the mass of the Moon is 7.4 into 10 to the power of 22 kg. If the distance between the Earth and the Moon is 3.84 into 10 to the power of 5 km Calculate the force exerted by the earth on the moon. And the G, the gravitational constant, is 6.7 into 10 to the power of minus 11 Newton meter square per kg square. Nm square kg to the power of minus 2. Here what is given? Mass of the earth is given, mass of the moon is given. Note down that. Take the solution. So let us consider the mass of the earth is capital M and mass of the moon is small letter m. So take the mass of the earth m equals 6 into 10 power 24 kg. Mass of the moon, the mass of the moon equals, let us consider that is a small letter m, equals mass of the moon equals 7.4 into 10 to the power of 22 kg. So right, 7.4 into 10 to the power of 22 kg, 10 power 22 kg. The distance between the earth and the moon, that is d. Distance between earth and moon. Earth and moon. So you write earth and moon equals, it is 3.84 into 10 power 5 kilometer. 3.84 into 10 to the power of 5 kilometer. Then here you convert this into meter, equals 3.84 into 10 power 5 into 1 kilometer equals 1000 meter. So you write 1000 meter. Then it becomes 3.84 into 10 power 5 into 1000 means 10 power 3. 10 into 10 into 10 it is. So 1000 is 10 power 3 meter. Then you can write it is 3.84 into 10 power 5 plus 3. 5 plus 3 is 8. If you use the law of exponent, a power m into a power n equals a power m plus n. 10 power 5 plus 10 power 3 equals 10 power 5 plus 3, that is 10 power 8 meter. Then the gravitational constant G is given, that is 6.7 into 10 power minus 11 Newton meter square per kg square. So you write G equals 6.7 into 10 power minus 11 Newton meter square kg power minus 2. Now here what you have to find out? Calculate the force exerted by the earth on the moon. Calculate the force exerted by the earth on the moon. So you write the formula for force. Gravitational force equals, according to the Newton's law of gravitation, G into m into m, that is the G into mass of the earth into mass of the moon divided by the square of the distance between them. G m into m by d square. Then you substitute the values of G, m, and d. So what is the value of G? G is 6.7 into 10 power minus 11. n m square kg power minus 2. Then m is mass of the earth. What is the mass of the earth? Mass of the earth is 6 into 10 power 24 kg. 6 into 10 power 24 kg plus. Then mass of the moon. Mass of the moon is 7.4 into 10 power 22 into, you write, into 7.4 into 10 power 22 kg. That whole divided by d square. D is what here? D is 3.84 into 10 power 8. 3.84 into 10 power 8 meter d square. So you must write square of 3.84 into 10 power 8 m whole square. Then you write that equals. So you take 6.7 into 6 into 7.4 together. 6.7 into 6 into 7.4 into 10 power minus 11 into 10 power 24 into 10 power 22 into n m square kg power minus 2 into kg into kg. So here you take this together. And here what I have taken together? 6.7, 6 and 7.4 together here. And 10 power minus 1, 10 power 24, 10 power 22 together. That is 10 power minus 1, 10 power 24, 10 power 22 together. Next the units. This and this together. Next that whole divided by, that is 3.84 into 3.84 into 10 power 8 into 10 power 8 m square. This 2 time, this 2 time and this 2 time. It is a power, second power. That is the square of this, means you must write 2 time. Then that equals. Here 6.7 into 6 into 7.4. If it is possible, try to cancel it, or otherwise here there are 2 digits after the decimal point. So you can this cancel here. 67 into 6 into 74 and 10 power minus 11, 10 power 24, 10 power 22 is there. Then you can write 10 power minus 11 plus 24 plus 22 n, and here m square and m square cancels, so cancel, and this also cancels. That is or you can write it as kg power minus 2 plus 1 plus 1. Here it is 1 1 you can take. That divided by 3.84. Here one decimal point is cancelled. 384 you write. Then 3.84 into, that is 10 power 8 plus 8. Use the law of exponent here. That equals, if you want to multiply, you multiply, or otherwise you can cancel here. 2 3s are, 2 1s are, 2 9s are, 2 2s are. Then here 9 plus 1 10, 10 plus 2 12. It is divisible by 3. 3 1s are, 3 6s are 18. Then 1 2, 3 4s are. Then again here you can cancel. 2 3s are, 2 7s are, 2 3s are, 2 32s are. Next what is remaining here? 67 into 37 into, this is 24 plus 22 is 46 minus 11. Minus 11 is 6 minus 4. 1 is 5. 4 minus 1 is 3. So you'll get 10 power, how much? 35 into n. Here this cancels. It becomes 0. So kg to the power of 0 means kg to the power of 0 is 1. That divided by 32 into 3.84. 32 into 3.84 into 10 power 16. 10 power 16. Then you multiply this to 67 into 37. That is 7 sevens are 49 and 7 6 are 42 plus 446 plus 7 3s are 21, 6 3s are 18 plus 2 20. It becomes 2479. 2479 into 10 power 35 and 10 power 16 is there. So you write 35 minus 16. That divided by, you multiply this to 32 into 384, or you write 384 into 32. 4 2s are 8, 8 2s are 16, 3 2s are 6 plus 1, 7, plus 8 4 3s are 12, 8 3s are 24 plus 1, 25, 3 3s are 9 plus 2, 11. It is 8, 8, 12 and 2, 1. So it becomes point is here 3.84 means you will get 122.88. Then it becomes 2479 into 10 power 35 minus 16. You will get 19. 15 minus 6 is 9 and 2 minus 1 is 1. 19 by 122.88. Now here you remove this 2 point here and take 2 zeros above. 247900 by 122.88 into 10 power 19. Now try to, here it is divisible by 2. Now you cancel it. 2 6 are 2 1s are 2 4s are 2 4s are. It is 2 1s are 2 2s are 2 3s are 2 9s are and 1 2 5s are 0 again. 2 3s are and 0 2 7s are 2 2s are. Then it is 2 6s are 2 1s are 2 1s are 2 1 9, 2 9s are 18, 1 5, 2 7s are 14, 5. Then you divide 61975 by 3072. That is 2s are becomes 2 2s are 4, 7 2s are 14, 6, 7 minus 4 is 3, 9 minus 4 is 5 and 0 0. Then next to take 5. So it is not divisible by, put 0 and put the decimal point and take 0 here. Then it is 1, 1s are 3072. 10 minus 2 is 8. Then 15 minus 7 is 8. 2 minus 0 is, and 2 is remaining here. It is 2 and 5 minus 3 is 2. Then you take next 1 0. It is approximately, can have 7 here. 7 means 7 2s are 14. 7 7s are 49 plus 1, 50. Then 7 3s are 21. So this much is enough here. So you write that is 20.17 into 10 power 19 Newton. Or you can shift this 0 to the right side of the point. It becomes 2.017 into 10 power. Here again one more power increases for the 10, that is 19 power 19 plus 1, that becomes 20 Newton, as this 0 is shifted to right side. So here we have to take 1 power for the 10, that is the extra plus 10 we have to take, that becomes 20.17 into 10 power 19 means 2.017 into 10 power 19 into 10, then becomes that equals 2.017 into 10 power 19 plus 1, that becomes 2.017 into 10 power 20. What you got here, that is the answer. So you write, therefore the force exerted by the earth on the moon is 2.01, approximately 2.01 into 10 power 20 Newton. That is the force exerted by the earth on the moon. Importance of universal law of gravitation. What are the importance of universal law of gravitation? Universal law of gravitation successfully explained several phenomena like the force that binds us to the earth, the motion of the moon around the earth, the motion of the planets around the sun, the tides due to the moon and the sun. So read that universal law of gravitation successfully explained several phenomena like the force that binds us to the earth, the force that binds us to the earth, the force that binds us to the earth. Second, the motion of the moon around the earth, the motion of the moon around the earth. Motion of the moon around the earth. Third, you write the motion of planets around the sun, the motion of planets around the sun. Fourth one, the tides due to the moon and the sun, the tides due to the moon and the sun. Tides in the sea forms due to the gravitational pull of the moon and the sun. So these are the phenomenon explained by the universal law of gravitation. So these are the importance of the universal law of gravitation. Now let us write the answer to the in-text questions. What is the first question? State the universal law of gravitation. Write the answer. What is the statement of the universal law of gravitation? Every object in the universe attracts every other objects with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of two objects. That is the statement here. The second question here, write the formula to find the magnitude of the gravitational force between the earth and the object on the surface of the earth. The force of attraction between the earth and an object on its surface is given by. Here the formula is F is equals to G m by d square. But here the d is, that is the radius of the earth. D is the radius of the earth, that is the distance from the center of the earth to the surface of the earth. So let us take that is r square. So you write that, what is G here? G is the gravitational constant. G equal universal gravitational constant, and m equals mass of the earth. M equals mass of the earth, and small m equals mass of the object on the surface. Mass of the object, and r is the radius of the earth. Radius of the earth. Here we have considered that the whole mass of earth is concentrated at its center, and r is the radius of the earth, that is the distance between the center of the earth and the point on the surface of the earth, that is at which the object is there.